real data with all its warts and ugliness is the holy grail.
LLMs do two things. They understand and they generate.
It's validating that we'll be able to just move much more rapidly and do more and more.
The feeling of progress is the thing that keeps things engaging.
Of course, like everybody else, we started with GPT because that's easy. Ultimately, for customers, they want to feel like they're having progress. Our situation's a little bit more complex because, of course, voice is a trickier beast.
The whole human in the loop thing is more critical than ever.
We're seeing that the customer satisfaction and the solution rate. So, did we solve your query? This is skyrocketed in comparison to what we had before. So there is, a real benefit there already.
You hear a lot these days about kind of like orchestration. Across all channels, what you really want is AI orchestration. You want the AI systems to be understanding where best is this use case served. This episode of VUX World is brought to you by NLX. NLX is the enterprise conversational AI platform that enables some of the world's most admired brands to build and manage chat, voice, and multimodal applications at scale. So if you are looking for a platform to power all of your conversational automation initiatives, you're looking for something that's enterprise grade, something that gives you the flexibility and control to create the kind of experiences that you know your customers need, then check out NLX. You can find out more at nlx.ai. That's nlx.ai. Thank you, NLX, for sponsoring VUX World. The following is a conversation with Katherine Munro, who's a conversational AI engineer at Swisscom. This is Swisscom's third appearance on VUX World, believe it or not. And this conversation is incredibly deep. This conversation is about AI-enabled classification using generative AI and large language models. Now, many of you listening to this have classification systems. If you've got a chatbot and you're using natural language understanding in that chatbot, essentially that's all that's doing. It's classifying a customer utterance and it's trying to match it to something that you can help them with. If you were to replace that with generative AI, how would you go about doing that? And what kind of foundational capabilities do you need in order to do that? What kind of testing do you need to make sure that it's doing the things well that your current NLU system does, and how to get better than your current NLU? More importantly, perhaps even than that, is that in the world of AI orchestration, which is becoming a very hot topic at the moment, how do you orchestrate your existing self-service options? How do you orchestrate handing over to live agents for the relevant intents and skill sets? How do you orchestrate different AI agents that are fulfilling different capabilities, either amongst each other or getting people into the right agents in the first place? All of that requires a very good understanding of the customer need, and that all starts with classification. This conversation right now with Katherine is a foundational conversation that anybody interested in you leveraging AI to be the front door for your business or the front door for all of your agentic applications, this is a foundational conversation that will enable you to do that. As I said, it's very deep, it's very insightful, and you're going to learn a hell of a lot. Get your notepad out right now because you're going to learn so much with Katherine Munro on VUX World. Hello, Katherine. How are you?
I'm good. How you doing?
I'm
Thanks
all right.
for having me.
Thank you for being here. This is for Swisscom the third occurrence for Swisscom on VUX World.
Yeah. Do I get a hat?
Maybe Swisscom as an entity should get a hat, and you could easily well be one of the recipients of that. Yeah. Maybe I'll have to send everybody a hat. Yvonne and Roger and yourself. Maybe everyone should be entitled to a hat, perhaps.
Yeah.
Nice. Well, I appreciate you.
It was really nice for me to listen to the old episodes because I've only been at Swisscom for just over a year. So your episodes were from before I started. It was really nice to get that history and to realize what got us, what decisions we made to get us to the situation that I've now landed in as a newbie. So yeah, that was pretty cool.
There you go then. Yeah. VUX World should be part of the onboarding experience for new people at Swisscom, is what you're saying.
Recommend it.
Nice. Yeah, that's funny actually, because there's been quite a few episodes like that where, like certain companies we've had on every year for a long time, for many years, like VoiceFlow and Cognigy and Core and others. Like, it's interesting to sort of like track the journey and see how things are all developing really. And I think at Swisscom things have developed in the last kind of few years since Yvonne was on here last, in terms of your usage and experimentation with generative AI and stuff like that. Am I right?
Yeah, definitely. Yeah, I was able to join. I remember in my interview, they said they're basically going into a bit of a startup phase, at least within the conversational AI division. And that's one of the things that appealed to me. And yeah, it was 1,000 things going on at once in the best way. And yeah, and what we've managed to do since then in that 1 year has been pretty amazing. So yeah, good times.
Nice. Yeah, that's good. That's good. Nice to see that it goes in the right direction. I think it's interesting always when you're a fairly large company and you have a solution already and it's working fairly well, and it's kind of like it's what is it? It's seeking gains rather than minimizing losses sometimes with established companies, with established chatbots. I mean, there is some
Mhm.
losses because NLU is not perfect and stuff like that, but at least you've got a stable system that ought to be doing
Mhm.
what it should do most of the time. And so the kind of searching for that next level, that extra gear, what can generative AI kind of give us? Like, what was the thought process that you sort of went through to try and establish the best place to put this technology in terms of your existing solution?
Well, basically, as they explained to me in my interview, they had already some pretty advanced chat and voice bots that they'd really iterated on for a couple of years. And those bots had some self-service use cases, some FAQs, and of course routing to agents. But they had started to hit a plateau of the improvements that they could make. And in the interview, I couldn't understand what that even meant. I just knew that sounded exciting. Once I started, I realized that it's things like adding end-to-end use cases. The more of those you add, the more complex the logic is. And when you're doing this with a relatively rule-based sort of logic, it's so hard because the like any combinatorial, sort of explosion, there's so many paths you can and need to implement, and so it was just becoming intractable. So yeah, that's the war stories that I got once I started. Basically, I started at a time where we were trying to figure out, there was these hypotheses. Okay, we can fairly quickly get to what we've already got using LLMs. And if we can do that, really quite quickly and to a good quality, then that indicates to us that future additional functionality and stuff will be so much easier than it's ever been before. So, it's validating that we'll be able to just move much more rapidly and do more and more. So when I started, it was so we use these 10-week product increments, and so there was 3 product increments planned for just getting a POC little chatbot working. Can we do it in this time? And the answer was yes. And of course, I was too new to the field to realize how remarkable that was, because I'd never had to slog through, coding a flow into Neo or something like they had. But that was a big deal. And so that's how they decided to do that. They validated that hypothesis. And once that worked, then we reshuffled the teams a little bit to sort of better suit this new way of working. And we formed a new voice team to start that whole process again, basically, but for the voice bot. And I jumped into that team because I thought that sounds like a nice challenge, especially for someone with a NLP background like me. And so that's what I've been working on for about 9 months now. And so we're kind of following in their footsteps.
Yeah.
And yeah.
Interesting. So most of it, or everything was on NLU based architecture, rule based, and as you've
Mhm.
gone through this process of initially beginning with the chatbot, moving into voice, you've steadily been going through, and what specifically have you been doing? You've been replacing the full end to end with generative AI. You've been experimenting with different components of generative AI. Like, where is the generative AI components being experimented with, and where are you finding it's being most useful?
Yeah, so you're right that the old system is this classic NLU-based system where usually you have machine learning models detecting the intent and the topic. That's what we had. And then, there was some relatively complex logic to sort of take those predictions, maybe combine that with a little bit of syntax rules, some extra business logic that's easier to just maybe encode as a bit of string matching or contextual data, based on whether the customer has, I don't know, an open order or an open service ticket. And from there, we're getting the routing targets, and these customers are either getting routed to an actual customer service team or maybe one of the self-service use cases. We did have a couple, like especially in billing, things like getting a copy of your bill, and then anything else could be just captured with this FAQ fallback. So that's what we had. And with the chatbot, we basically were using a new chatbot builder framework, a model agnostic framework. Of course, like everybody else, we started with GPT because that's easy. But we are also separately experimenting with fine-tuning our own models and stuff like that. But basically, this chatbot is the large language model is just being built onto this framework, and the framework is essentially a giant prompt that explains all the different business processes and things that we have, and the LLM can choose the best one. And I really like the way you always explain it in your show. We don't need to have an agent system that gets points for figuring out how to do the task on its own. This is logic that has existed for years. And there are, for example, legal processes and security processes that have to be followed. So there's no need for the LLM to make that up. It's just figuring out what is, the best business flow to trigger now for this process, and it's triggering that. That's what we started with, right? That's the chatbot. We have a separate team now that's working on the RAG component, and actually this team is building this answer as a service, not just for the chatbot team, but for any team at Swisscom that wants to build their own answer as a service thing. So that's a really nice modular component with really great engineers working on it, so that any team, the HR, they can make their own little chatbot if they want, or things like that. Their own little RAG-based bot. So we've got that. And now we come to the voice bot, my team. With ours, our situation's a little bit more complex because, of course, voice is a trickier beast. It is harder, and we have so many interfaces with different systems for, authentication, pulling up customers, contextual data, things like this. And we also have some architectural, how shall I say, some needs we have to fill at the moment, which means that we're not able to start with a completely sort of greenfield bot that would be very exciting and cool to do. I'd love to do that, to just say, okay, how would I build the best, most amazing customer experience that anyone's ever experienced? We can't quite start like that yet. Instead, we do have to sort of one piece at a time re-implement existing functionalities in this voice bot builder framework using the LLM, just so that we can make sure that eventually we have feature parity with what there is now. And then later, in about 9 months, we'll be able to really let loose and build the best thing ever. And I can't wait for that. But for the moment, it's very much step for step. First step, you've got your intents, right? What does the customer want? How can we get the LLM to recognize those intents? Next thing will be, okay, we have some existing end-to-end use cases. These are self-service use cases. Can we get the bot to recognize those and trigger those? Next thing is, we have some customers where they're calling about a sensitive topic, so we'd like to rush them quickly through to an agent, but can we get the bot to detect those? So for my team, at least, all our work so far in these 9 months has been very much basically classification problems with LLMs, which is a little bit unusual, but that's what we've been working on. And then, but we're still then just passing the labels back out to the rest of the system for it to do its thing. But we will absorb more and more of that functionality until eventually it'll be in one place in the framework, so that we have full control of the end-to-end experience. And then we'll be able to let loose from there.
Interesting. So make sure I understand this correctly then. So someone calls, when they call, they will at first instance interact with your LLM that you've tuned for this classification use case, you find out what the intent is, and then you would then essentially post that back to your original platform into the appropriate place. So this use case will begin, or this use case needs to be escalated to an agent, so we'll trigger that escalation process. Am I understanding that correctly?
Yeah, exactly. So you can think of the existing system like, little microservices or little boxes, and each box, takes up something in and spits something back out to go to the next thing along the chain. And so right now, we've just overtaken the first part of the chain, which would have been those machine learning models in the past. So now, instead of using those, we're using the LLM, but we're just spitting it back out to the rest of the system that manages things like the actual routing to the customers or the triggering of the use cases. So, for example, the use cases, right? If you want to register your move that you've changed address, that already exists as an end-to-end use case, but it's not in our conversational platform. So it's not conversational yet in the nice fluid way that LLMs will make that possible. But that is one of the steps on the not too distant horizon, is can we absorb now those end-to-end cases so that people can do it in a much more conversational way? Right. And it will just keep going from there. Yeah.
But those end-to-end use cases currently, they are voice-enabled via NLU, or they're triaged to a different place like the mobile app or something like
that? Some of them are going to the mobile app. A couple of them, I think, are end-to-end, but based on old CIVR technology. So a bit more, if this, then say this. I think the best ones in terms of the customer experience are done in the app. So because a lot of our customers, we find they really like our My Swisscom app. They're quite familiar with it. But if it's the first time they've encountered this problem, they just don't know where to go. So once they call and get sent a link to exactly the right spot, then they're happy and they take care of it by themselves.
Yeah, that makes sense. So you mentioned just then, and the few articles which we'll link to here as well, which you've written on this topic, which are really great. You always begin with, it's a bit of a strange use case for LLMs to classify an intent. Now, from my perspective, LLMs do two things. They understand and they generate. So I'm curious about why you think it's a strange thing for LLMs to be attempting classification. Why is that sort of like a non-traditional use case for LLMs for you?
Yeah, the thing is, it's strange and it's not strange when you think about it. So on the one hand, it's strange because it's completely over the top, right? You don't need a trillion parameter classification machine, because old school machine learning models have done a pretty good job when it comes to classification. Like in the past, they've actually been pretty good, especially if you're fine tuning them. They do a really decent job, and they're very fast, cheap, lightweight. They're not adding a ton of latency to the whole process. They're a bit more interpretable. You can really have a labeled test set that you can benchmark against progressively each time you retrain and all that. So there's a lot of simplicity and a very good effectiveness to using, an old school NLP model, or NLU model, sorry. And so to now throw trillions of parameters at that problem, that's the first thing that's a bit strange. The other thing that's a bit strange is, LLMs, they want to talk and talk and talk, a bit like me. Whereas when you have a classification problem, you want one label. So you're telling it, stop talking and give me one label. Also, with classification, you usually want it to be really consistent, right? You want the same input to give you the same output. And we know that LLMs are not great for that either. So for all those reasons, it's maybe a little bit strange. In summary, LLMs are slow and random and not at all interpretable, and that's not what you want in a classification system. But there's lots of good reasons to use them anyway. But do you want to object to that, or I don't know, dig into that?
I don't object to it. No, I think that's I concur with that general sort of sentiment, which is that yes, large language models are fairly slow. You could argue that small language models might be a little bit quicker, more potentially more effective. They definitely want to just talk at you all the time, and controlling them is definitely a challenge. And also, it's not yet a fully solved problem, the concept of hallucination. And as much as various benchmarking kind of like results may suggest otherwise, I always have the kind of thought that benchmarking data is benchmarking data, and it's not necessarily representative of the real world. So what happens when you put things in the real world, the hallucination problem definitely hasn't necessarily been solved. So definitely concur with all of those things. For my, experience, it's been that small language models offer the greater opportunity, but I'm curious to get your perspectives on it, because obviously you've done quite a bit of work on this. So yeah, what's the starting point for you then, moving from an NLU based system to an LLM based system? What's the first things that you need to consider? What did you do essentially? What was your process?
Yeah, well, as I said, so far we mainly only experimented with GPT-4 and GPT-4o. And with the framework that we have, you essentially describe all of your business logic in one giant prompt. So, you're telling the bot that its job is to figure out these different business processes, which of them is the most appropriate for customers, and it can ask follow-up questions and things like that. So you basically just need to have really good descriptions for those different business processes. And so that's what we, of course, started with. And then we really did do benchmarking in the sense that we, because we know we need these labels out, we know we need to figure out what is the correct customer service team, what is the correct use case, and so on. We made that effort to label some data, and then we run simulations where we'll write all our different descriptions of the different business processes. These are all compiled into that one big prompt, and then we really trigger the LLM 1,000 times with 1,000 utterances from production. So you're just taking the first thing the customer said, sending it into the bot, and seeing what it predicts. And that has been really useful. On the one, first of all, the first promising thing we noticed with this is that, out of the box, this just really few shot prompting was still getting 70% accuracy on the first go. And of course, your first prompts, your first descriptions are never perfect. And we found that we got quite a nice increase in accuracy when we would then look at, say, the confusion matrices of, if it was supposed to be the billing team and instead it predicted the admin team, how often was that happening? And then we can tweak the descriptions, and we can do this for all the different labels that we have. So we did that. We also then we experimented with GPT-4 versus 4o. 4o is cheaper and faster, so of course we were hoping that would work equally well. We found that in general it did work equally well. We have noticed, or we have a feeling, that it hallucinates some when it has to extract details. It maybe hallucinates a little more, but that's something we need to look into. But yeah, basically that was the thing. And iteratively, the thing is, we don't start with all our business processes at once. We started with the basic ones about the different customer service teams. Then we run a simulation, we see how good it is, we change the descriptions, and we repeat. And then when we think, okay, that's pretty good now, then we add new extra business processes, which are the triggers for these use cases. So we add more descriptions, run the simulations again, check the accuracy, tweak, and repeat. And that's how we've been doing that. And that's been working, pretty well so far. The big limitation of that approach is, so far, when we want to do this at scale, it's only been convenient so far to send the customer's first utterance to the bot.
Right.
So because taking lots of end-to-end conversations from prod, 1,000 end-to-end conversations and triggering those, we haven't got a super perfect way to do that. That's one of the blog posts that I sent to you is exactly this problem. And it's a problem that I think is not well enough tackled by any of the tools that are out there either. So when we do want to test end-to-end behavior, we can do these we manually write some end-to-end tests that we can then run automatically. But that's not something you can do at the scale of a benchmark data set, like we do for the first utterances. So we basically use this mixture of evaluation methods. Like we have these automated end-to-end tests that are written manually, but there's not too many of them. That's really testing the basic functionality. And then to capture more of the scale and the diversity of how customers talk, we run these simulations, but only on the first utterance.
Right.
But yeah, so it's not perfect, but so far that's been working pretty nicely.
And so the first question then, I suppose, is where you get these utterances from, because in order to either you take them from the old chatbot or voice bot, or you take them from calls with agents, or you just put something live that's kind of doing nothing and you just kind of collect them. How do you go about getting hold of that initial data set?
The initial data set is just coming from prod. It's from the old system.
Right.
And that's actually super useful because we can see what the old system predicted. And what we can also compare is for the old system, we have its predictions on the first turn. So whatever the machine learning models predicted with the first utterance from the customer. And then, the old system, or the current system, let's call it current, it's still the live one. It also has the ability to ask clarification and disambiguation questions, right? And it's also got all this massive domain knowledge encoded as logic rules and syntax matching and stuff, and working with contextual data to sort of take that initial prediction and update it based on, the answers to the follow-up questions or all this other information. And that's really nice because now when we do a simulation, we can say, okay, what was the existing system's accuracy on the first turn? And how does that compare to our simulations now? Because our simulations, as I said, they're also only using the first turn. And what we found is that's quite close. And then we can see, okay, and the live system is then better on its final turn because it's got all these disambiguations. And with the simulations, we can't test that yet because we haven't got this ability to test the end-to-end conversations at scale yet. But once that happens, we'll be able to really, really nicely compare, apples with apples. So that's what we do, yeah.
Right. So you grab that test.
And as I said,
no, go on. Yeah,
sorry.
Yeah, go on.
Just jump in. As I said, we do make the effort of hand labeling these, and that even includes the disambiguation targets. So that's quite interesting because we have, as part of our new bot that we've built, we have these processes that we described. They also should lead to specific disambiguation questions if it's unclear. So, for example, if it's really unclear so someone says, I'm calling about my mobile, but now we don't know if it's, say, an administrative issue, a billing issue, or a technical issue, there's a specific question that should be asked, and the LLM should ask that question. And so our labeled data set is not just the end target, but it's really what should the bot predict when this is the only information it's got. And that way we can really look and make sure that we're also triggering the correct disambiguations, which of course gives us then confidence that it's going to get to the correct answer eventually. So even if we can't end-to-end test all these conversations at scale yet, we can say, well, it's probably going to work quite well because it has asked the correct clarification question. And most of the time on prod, when it asks that one clarification question, the customer supplies the final bit of missing information, and then we're good to go.
Right. So just stepping back to the data again. So you've sourced some data, and you want to then be able to see whether or not this new classification system using LLMs performs better than the old one using NLU. So you've got some data from the chatbot from the old NLU system, and you have a prompt which you mentioned. Essentially, you just describe all of the business processes that exist in the system, all the use cases presumably that you want to be able to route to, all the types of agent teams with whatever skill sets and the type of queries that they need to be able to handle. And so you've kind of given one prompt with this kind of like description of the environment, if you like. The next question then is, you then presumably take that prompt. In there somewhere, there is a space for you to put one of these utterances, correct? Yeah. And then you have some kind of program that will, over a period of time, concoct that prompt, inject the utterance, test against the model, retrieve a label, and then over 1,000 utterances or so, you're then grading every one to say, is this correct or is this not correct? Is that roughly speaking what's going on?
Yeah, it's roughly right. This testing program is me with my Jupyter notebook,
Right.
But so yeah, but basically it's just you're just making an API call. So all we're doing, I've got my data, right? My 1,000 labeled data points. I turn each one into like from the string that it originally was. So you've got the custom utterance. I wrap that in, the format that it needs to be, that the bot would expect in a normal conversation. I simply make that REST request. So I'm calling the bot's API, getting its response back, saving that, and then I've got another notebook that then compares, what is the ground truth versus what was predicted, and generates all the fancy graphs and things like that, and then we're manually looking at it. So it's not a my colleague makes this great distinction between exploration and observation. So exploration is what we're doing now, because we're still building this thing. So we need to be confident when we make a change that we've made an improvement. Observation is what me as a data scientist, I think of things like ML ops. When you have a machine learning model that's running in production, you don't want to be observing every single thing it does in excruciating detail, but you want your aggregate metrics of, how often is it triggering the different customer service teams every day, or the different use cases. Those kind of aggregate things we'll want eventually. And so we will want to have this kind of thing running automatically, but we're not even up to that yet. So at least not with the voice bot. So it's still a manual process, but that keeps us really in touch with how the bot behaves. And I actually think that's really important for any team that's starting with this. It's no good to just think, I'm used to talking to GPT, I know how it behaves, so I know how to prompt it. You need to get used to trying and failing to get it to recognize the correct intent for your customers and the kind of things that they say. And so, yeah, that's why I think actually this relatively manual process has its benefits.
Yeah, well, most of them are manual processes anyway, to be fair. And with this type of technology, I think the whole human in the loop thing is more critical than ever. So you're testing against the actual bot's APIs, which means that the prompts that are behind the scenes that are built within the bot have already been designed. Is that correct?
Yeah. So all that business logic is written. It's compiled into this giant prompt, and we're just hitting that prompt basically. And of course, this framework can trigger the different kinds of disambiguation flows and so on. And so that's why we're able to see, okay, for this utterance, did it correctly trigger this disambiguation question? Or if the ground truth is actually it should have gone to billing, then we'll be able to see, okay, did it figure out from just this one utterance that this customer needs to go to billing?
Right.
And we can compare that. Yeah. And then we can compare to the production data, like the original labels from prod, and see how's that accuracy.
Right. So in the disambiguation situation, which has got a nice rhyme to it, the disambiguation situation, that will then do the same thing as it would do if it's accurately identified a use case. It will go back to the NLU model and it will trigger the disambiguation for that utterance. Am I understanding that correctly?
Yeah. So on that first utterance, if the right response is, oh, I don't know, actually, I'm not sure, then it will disambiguate. And so we know we can also look at out of the different possible choices that it had, are we satisfied that it was confused in the right way?
Right.
Because if you know what I mean, like if it's clearly also to a human a bit ambiguous between okay, this is clearly about a mobile phone, but we don't know if it's admin or a technical problem, then we would expect our bot to have the exact same confusion. And if it instead is confused between two completely other departments, then we'll also see that and be dissatisfied with that.
Right.
And what we can also do with this approach, this is the second thing we use these simulations for, is it's not about comparing to any ground truth, but it's just about seeing how our bot behaves and how that compares to the existing system. Now, what I mean by that is before we had implemented the disambiguations, we needed to know which disambiguations to implement first, because we can't implement all of them at once. There's just so many possibilities with all the different business processes we have. So, we just need to start with a few. And so therefore we can run these simulations, and we're not interested in how does its prediction now compare to any ground truth. We're just interested in how often does it confuse flow A and flow B as opposed to flow B and flow C. Because when we see, these two concepts are really frequently confused by the bot, then we know we can implement a specific disambiguation for that. And when we see that one time in 1,000, it's confused between A and Z or A and Z, then we can, then we know, okay, that's not worth implementing a disambiguation for. So in that case, we'll just ask the customer again a bit more generally, like, sorry, can you please explain that again?
Interesting. That's really good. So you mentioned at the beginning, the first time you tried it, you were getting something like 70% accuracy or something like that, were you? Where did it end up in the end?
That's a bit of a tricky question because we run our simulation, in my team at least, we have these different kind of, let's call it the conceptual areas, like one is about the intent, one is about the use case. And so depending on those, it's the values are a little bit different, but I would say the last tests were, between 80 and 90%, something like this.
Fair enough.
And this is, it's a work in progress, so that's only going to get better. I hope.
Yeah.
You never know with LLMs; they can always turn around and sort of ruin your day. But I think that will get better.
But that's the question, isn't it? Like the kind of like it's a bit like, if you take like I don't know, retrieval augmented generation, or you take like an agentic approach in inverted commas, because I don't like using that word because most of these agents are not agents, but anyway, if you take that approach where essentially you're describing the business logic using language and you're providing tools to this thing that describes what the tools are, and you're telling it use this tool in this situation, etc., 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 and manage this workflow. In that scenario, to get a prototype together, very simple. And to make that prototype do 80% of what it needs to do, fairly straightforward. Same thing with retrieval augmented generation. To ingest some data, to have that data be retrieved relatively accurately, fairly simple to do. To get that accuracy to 99%, which is what most banks would want it at, or higher, very, very difficult. To get an AI agent that can do this business process 90%, 99% of the time, quite difficult. So it's like, it seems to me as though like the process of getting LLMs to do something to a sufficient standard is reasonable, but getting them to get to a really high standard seems to be particularly challenging. I don't know if you're anticipating that or finding that, or any thoughts on how you squeeze that extra 10% out of it, or does it even matter?
Yeah, well, there's so much in that. Firstly, I'm surprised that you say that a bank would expect to get 99%. I mean, of course, in terms of triggering certain actions that have an actual impact on the customer's account, then this needs to be, absolutely watertight. But that's not that final part. I don't think they're going to be doing with an LLM anyway. I have a feeling. But I feel like a lot of these systems that are out there in the world, their current accuracy is only, say, 80% or a little higher, and that's already pretty good. And occasionally some customers get wrongly routed, and that's bad, and I really don't want that to happen. But even when they get wrongly routed, it's the team at the end can usually solve the problem, which is one thing that makes it tricky to get. I'd love to be able to get labels automatically from our data set instead of having to hand label them by just going, okay, what was the intent? And did the customer say that their problem was solved at the end? But the problem is they could go to the wrong team, and that team will solve the issue anyway. So I don't think we need to get to 99% to give a great customer experience. So we probably won't be trying to squeeze out the best in that regards. I'd rather concentrate on making the experience more intuitive, more conversational, giving customers different options. So we always get contrasting feedback. For example, some customers, they really want things solved with the chatbot. They want it solved end-to-end in the chat. And others, because they're a really big fan of My Swisscom, as I mentioned earlier, they say, no, I want a link to My Swisscom, but it better be a personalized link. Don't send me to a page, send me to the exact sentence that I need to read. And I'd love to be able to offer both solutions to customers, to sort of say, all right, I can send you a link now to the My Swisscom, or would you like to solve this here in the chat, and give them a choice. So I think that's, for me, that's where the big reward is for the customer, because as I said, the routing we can usually handle if it's not quite right.
Right. So
didn't I answer all the question? Because when you were asking me, there was so much stuff going in my head. I should have taken some notes, because I feel like there was some really juicy bits in there that I have now forgotten.
No. Well, I think the general sentiment is that you're not concerned necessarily about reaching 100% accuracy in all cases. You're concerned with, essentially doing, I suppose, better than what it currently does, but then secondly, giving yourself the foundational capabilities to be able to build on top of, to create more natural experiences in future. So would I be right in thinking then that your hypothesis is that in order to create these more engaging, more dynamic experiences, a precursor to that has to be to match the classification capability of the NLU chatbot? Is that your hypothesis?
I think that that's a pretty safe bet. I think if we had worse accuracy than what we have now, that would worry me. But and there's another reason why we want to have at least the same accuracy as the current system, and that is, of course, just the literal practical need to have the right number of agents in the right number of teams. So that's why sometimes we don't even need to simulate with a labeled data set to still get useful insights, because if we simulate and just look at the distributions that are being predicted and it's wildly different to what's live, then we know we need to do something about it, because we can't suddenly funnel 5 times more billing inquiries to the billing team than they're expecting. They just won't have enough people. So this is why we actually we want to mainly, at least for now, have the same kind of accuracy. And then I think in the future we'll try to get better and better, but we'll have to do that very much in tandem with those business teams, so that they know what to expect and they can adapt for that.
Yeah. And is it then at the moment reaching parity with the NLU model, or is it better or worse, or what?
For our accuracy, I'd say it's pretty similar for the voice bot, and the chat bots is I think even better. Since we diverge a little bit in the teams, I don't know the numbers off my head, but I think it's a bit better. And I just remembered something else I was going to say from your previous question, and because you were asking, about are we getting to that accuracy that we have, and is it seeing a good effect with the chatbot where we actually already are live? We're seeing the customer satisfaction and the solution rate. So, did we solve your query? This is skyrocketed in comparison to what we had before. So there is actually, a real benefit there already.
Right. So the impact of the classification in the first instance surely is better service, because you understand better, and therefore better resolution because you're not fumbling around and putting people to the wrong place, etc. That makes sense. So because essentially the question I was getting at there is that when you began at the beginning of this, and you were saying that it's a bit of an odd kind of use case for an LLM, given all of the trillions of parameters and huge size of the model, just to say, give me a label for this one sentence, compared to something like a machine learning system that does pretty much the same thing every single time. And the justification of the additional kind of effort, possibly additional cost, definite additional architecture revamp, certainly challenges on testing and QA, as you've been kind of exploring, the powers that be, at least if I was the powers that be, I would be saying, why are we doing all of this to arrive at the same result that we already had before? So I suppose that the story or the narrative there is that doing this, the goal is to do better than before, because if we can do better than before, we can prove in the chatbot use case that understanding people better gets people into the right outcomes, therefore there's a resolution rate increase. But also seemingly, you hear a lot these days about kind of like orchestration. And, across all channels, what you really want is AI orchestration. You want the AI systems to be understanding where best is this use case served, etc. And even in a sort of like multi-agent architecture, there needs to be one agent that orchestrates it all. And I think that wrongly, the assumptions in most of the community around agent orchestration is that it's simple because the LLMs will handle it all, you know? But I think the reality is that when you're
Yeah,
dealing with
it's
language,
simple.
yeah,
Yeah.
when you're dealing with language, you're dealing with customers, you're dealing with that thousands and thousands and tens of thousands of interactions per day or per week. You're operating at an immense type of scale, and not just when you're having like, a local example would be, your change of address use case that you referenced earlier. You may have a change of address agent orchestrating all of your change of address tools. And that's fairly straightforward because that one change of address agent just has the instructions about when to use what tools and when to do what and what the process looks like. But I think orchestrating the orchestrators is where the challenge is. And that's seemingly, presume I don't want to put words in your mouth, but like this is kind of what I would be thinking about if I was in your shoes, is that what we're doing here is we're building the front door so that we can orchestrate all of our use cases across all of our intents and needs in future.
Yeah, I think the having the front door is a really nice metaphor. And the thing that people shouldn't forget when they now go, we need an agent for everything. These end-to-end use cases like moving, register your move, that is implemented in my Swisscom with a really nice UI that a really nice designer has implemented. It works really well, is really comfortable. There is not necessarily any need now to make this a conversational thing. There are some use cases that just aren't as nice to do verbally. And so that's something people shouldn't forget. Don't now start to throw out all your old processes. And this is why your metaphor with the front door is so good. If you have a beautiful hallway that leads to a gorgeous, lounge room, then just bring the customer to the gorgeous lounge room and let them sit down, I think that is that's something that's a benefit of the way that we're doing it. We're not trying to now re-implement absolutely every single thing, but we will continually use customer testing to try to figure out what are the best things. And the other thing to bear in mind with this is there's also never going to be a right answer because, for example, some use cases, as I said, they actually don't make too much sense to do verbally. Maybe it's quite visual, or maybe it involves, for example, I don't know, setting up an installment plan. So if you're overdue on your bills and you want to now pay in installments instead, a lot of customers who have feedback, they want to be able to read that, see that, think about the numbers before they click OK. And some of them are uncomfortable with doing that entirely verbally. Others are fine with that. And that's the thing, you always get this contrasting feedback. But even accounting for the differences in people's desires in general, there'll also always be the scenario will also affect what's the best solution. So for example, there might be a use case that really does make sense as a channel switch to your phone, where we'll send the link to the phone because it's just a very visual task. It's easier to click buttons than, it's easier for me to click a date of the specific invoice that I want to get a copy of instead of saying the date out loud. But some people will call us while they're out for a jog because they don't want to waste time at home. So they won't want to stop and look at their phone. Others will call us while they're driving. I don't condone that, but they will. And I don't want to distract them by sending them an SMS. So I think that trying to throw away all these old services and convert everything to one kind of agent system is not necessarily going to be the best way anyway. And you're probably better off saying, okay, these processes work really, really nicely, but could we now see what other additional conversational possibilities we can offer to customers so they actually have a bit more of a choice? That's at least something that I'm thinking about and I'm excited about.
Yeah.
Does that make sense?
Yeah, absolutely. Yeah. We've been long proponents of the AI mediated triage approach, which is, don't throw out all of your old investments that you've, that work really, really well, leverage AI to get people to them and all that kind of thing. I mean, yeah, that makes total sense. I'm curious about the disambiguation pieces. So, for example, at the moment, I think you said that you're essentially just putting users back into the NLU architecture when you hit something that requires disambiguation. Is that correct?
Actually, no, not quite. No, so
All right.
the disambiguation flows are also implemented in the new bot. So the LLM is really controlling that disambiguation. Now, of course, we've explained to it the sorts of questions that make sense to ask. And so we've also explained that if a customer mentions phone, always treat that as ambiguous between whether it's a mobile or a landline. So then
Right.
the LLM can decide for itself, in that case, I'm actually unsure whether this is a landline or a mobile process I now need to trigger. And so then when it's unsure, when it's choosing between A and B like that, then we have the specific disambiguation question that it should ask. It can rephrase that. That's where we get the nice conversational aspect. But no, it's calling the shots as well in terms of the questions that it's asking.
Right.
And I'd like in the future to take that even further. So right now we've still got that relatively simple style of because also customers talk so simply, such keyword style at the moment. They're not used to speaking conversationally. But I imagine in the future that the bot should actually really drive a conversation like a human agent would, in terms of the customer just says, I was about to speak in German, then I'm so used to working in German. Technische Hilfe, technical help. The customer says technical
Right.
help. And then a human would say, all right, what's it about? And then the customer might still only say mobile. But then the bot, she'll say, what is it about the mobile? And actually ask a few more questions. There is this common wisdom that customers don't like to answer lots of questions on the phone. But I actually think that quote unquote wisdom is an assumption that needs to be challenged today, because I think in the old, extremely rigid, slow CIVR systems, that was true. Customers didn't want to do that. But in modern, friendly, dynamic text-to-speech-based conversational bots, I don't know that that's such a problem anymore, as ultimately for customers, they want to feel like they're having progress. And I think they won't even mind answering lots of questions until the point where the bot, maybe the bot asks 5 questions and then it finally knows, okay, I know exactly what this issue is. Now I'm going to send the customer to this technical expert with a nice summary that I'm going to generate about what we've already been through, so the customer doesn't have to repeat themselves. And obviously that's great, because you don't need to have the technical people going through so many tedious conversations with the customers as well. Just the very basic, have you tried switching your router on and off again? And you can get really straight to the kern of the kern. There's German again. The core of the problem, which is more engaging for the technical experts and a nice experience for the customer. Yeah, that's a bit of a deep dive from the topic of disambiguation.
Yeah, that makes sense. That makes perfect sense. I had a question there around kind of like, testing of those things. I had a different question. Progress is the thing that keeps things engaging. I think that's the issue with IVR systems, even the keyword-based ones, is it will say like a big long explanation about what you need to do and what you need to say, and then it will ask you to say something, and then you'll say it, and then it will a big long explanation again. And it's kind of like the design is terrible, so it feels really laborious. Whereas if it's just a quick kind of response conversation, I think that people will go for as long as they need to, as long as they feel like they're getting somewhere. But the question of like testing that. So there needs to be a time when the LLM makes its choice to say, I've got enough information now, I can label this accurately and I'm off. But that's not going to be the same every time, because people don't say the same things every time. So the nature of the disambiguation may well change, which is great, because you want that to be as fluid that goes with the conversation. I remember years ago in 2018, Google, from the Google Assistant team, they had this stat, which was that the number of ways that you could express verbally that you wanted to set an alarm was over 7,000. So you can say, I want to set an alarm 7,000 different ways. And then in order for that conversation to be contextual, if I say something like set an alarm, that might trigger, or I might even say something like, I want to wake up early tomorrow, or a bunch of different things that mean the same thing. Or in your example, technical support, I might say something like, I've got an issue with this bill this month. Now, the issue might be that maybe there's an issue with the bill and it's too high, and there's been a problem calculating it. But the issue might be I just can't make this payment this month because I'm struggling or whatever. Like, there's loads of little disambiguations that you need to do. And depending on what I say, that will then dictate what's said back, and then that dictates the flow of conversation. So I know that you've kind of mentioned that it's a work in progress, but where are your thoughts at the moment about testing these multi-turn conversations? Because I think that if that can be cracked, that's the thing that I think will enable more confidence and enable better risk mitigation from multi-turn, agentic, if you like, workflows, basically. Because at the moment, it's very difficult to assess the quality of those things, very difficult to assess the reliability of those things, very difficult to even test the prompts that you're using in these applications because of the amount of variability. So what's your kind of thought process thus far? Because I know you've done a little bit of thinking about it and stuff like that. So like, where have you arrived at the whole multi-step testing?
Yeah, exactly. The thing is that and first of all, you're right about, there's 7,000 ways to say I want to set an alarm. But there's also, when my first job intern at Mercedes, we're trying to, have voice user interfaces in the car. And, someone can say, I'm cold. And that actually means, can you please open the window? And that's important because they were trying to build that functionality into the cars that you could just speak to the car and it would put the window down. Put the window up. So you're absolutely right. And this is why the disambiguation problem is such a fun one. It's that's going to be a tough nut to crack. But so here's what we've done so far, my thoughts on it so far. So just to recap, first of all, we've got all our different business processes described. And when the LLM is unsure, then based on what it's unsure about, then we know which sort of specific disambiguations to trigger. And then it can also nicely rephrase those and ask those a bit conversationally. And in most cases, that'll then work pretty well. By the second or third turn of the customer, most of the time we can see, at least when we're testing it manually ourselves, that's working. So we're pretty confident in that the disambiguation process is working in general. But the biggest problem with that is that when the developers, our developers, our conversation designers, they are writing these business process descriptions and then testing it out with the bot. So they're even though it's a voice bot, we don't call it up straight away. We interact with it via chat, but it's the same architecture underneath. So we're testing it out. Then when we're ready to actually test how this goes, we have these end-to-end tests they can be run automatically. They need to be written, handwritten, and then you can run them automatically. So you can have your whole suite of end-to-end tests, and what you get as a result is a so-called diff. So I think short for differential or difference between at every single step of this end-to-end story that you've defined. It's what should have happened and what did happen. So the bot should have said this, but instead it said this. Red or green, did it work or not? Now that's very useful for making sure that our logic makes sense. So especially when we have decided, because sometimes you have special logic that, when we're disambiguating between topic A and topic B, actually it doesn't really make sense because the end goal is the same. So we will actually not bother with that. Or if it's a very sensitive topic, like the bot maybe thinks the customer is calling about a deceased person, a so-called case of death, we don't want to then ask, are you calling about a deceased person? Mm-hmm. This would just be uncomfortable. So we'd rather actually play that one safe, don't disambiguate, assume it's a case of death and send it to the right place. So we have those kind of specific logics, and these automated end-to-end tests help us just test those logic. But those tests are a bit like software unit tests in the sense that, they're supposed to test functionality, but you just write one for each piece of functionality you want to test. And the problem is, not only is that a lot of work to write, but the same people who are writing the business process descriptions, like describing it to the bot, are writing the tests. So when they're writing it, they say, I want a copy of my invoice. And then in the test, they write, I want a copy of my invoice. We know that works, right? What we really need is to test with a lot of customer data, because there are 7,000 ways to say, I want a copy of my invoice. And there's background noise, and the speech recognition, which is converting that audio stream into text, sometimes doesn't work. And we have customers talking in Swiss German. And in fact, we have customers switching languages mid-conversation, because in Switzerland, there are 4 languages that are supported. For all of these things, you need real data, the same as any machine learning problem. I mean, this is why you train machine learning models on X amount of data, and then you test them on a different test set. You want to see how does it perform in the wild. And yeah, this is the big challenge. And my idea is that basically most conversational systems out there, not just ours, but agent systems, anything that all the companies in the world are building, they have to track how the conversation's going, and they track this typically in a thing called a state. And so as long as we can overwrite whatever's in that state, then we can essentially time travel to any point of any kind of possible conversation and see how the bot would handle that. And that's my goal. I want to be able to say, for example, take 1,000 conversations from prod where there were 3 utterances from the customer with disambiguation questions in between from the bot. And I want to be able to take those and then essentially, I call it state hacking, because, but I have to be careful the FBI doesn't like hear me saying that too much. But I want to hack the state, right? I want to be able to then just inject that history into my bots and then see what it does. And that's how I think we can test, not just the disambiguation problem, but so many different things. For example, with RAG, usually just doing a query for documents with the first utterance from the customer is not going to bring very much, because the customer just says password. Yeah, there's 1,000 different documents that can come up for that. So maybe the bot then asks, okay, which password are you looking for? And if they say email, you also can't just send email to your RAG document retrieval search, because then you'll get a whole bunch of other documents that are irrelevant. So you need to concatenate them and say password.email. But maybe even then, you still want to ask another disambiguation question, and only then concatenate those 3 utterances and use that as your search string for your document retrieval. So that's another kind of thing that I think we will be able to test once we can crack this hacking the state idea. And so that's what I'm working on for us. And I think, any company who's building a multi-step LLM powered architecture, also an agent system, as long as they can figure out how to most realistically overwrite this state, then they'll be able to test things like that. And that's so important, because otherwise, as I think you touched on, otherwise you don't really get confidence in what you're doing until you go live. But therefore, what you do is you go live with a tiny bit of traffic at a time. And that means you might miss the edge cases that are the most important to catch, because it takes too long to ever go live in bulk. And so what would be great is, when I can simulate 1,000 multi-turn conversations from prod, then we can really have confidence and go live with more traffic faster, and get more and more real-time feedback. And so it will just speed up everything. So that's my thoughts. Does that make sense?
It makes sense. Yeah, I've got loads of questions after that. I know we're up on time. Are you good for a little while, for 5 minutes, or?
I've got time. And this is so much fun. I've even got old notes that I wrote from your earlier questions that are jumping around in the back of my brain. We probably won't even get to them, but I definitely have time.
All right, good. Because there's 2 things that come to mind here. So the first one is state management. Are you managing state within the LLM, or have you got something else that's keeping track of variables in a conversation, etc., and having that state managed elsewhere?
It's in the framework. So the whole framework upon which this giant prompt is built, and that does the API calls to the different systems, all that kind of thing. This is what's maintaining the state.
Right. So you're essentially then fabricating scenarios which presumably need to be designed beforehand, which is that, this customer wants to change their address, they've been authenticated, they've successfully given us their current, or confirmed their current address, and now we're at the state of being able to capture the postcode for their next address. So here's a bunch of samples of all the different ways that people will give you various different postcodes, and we want to then see what happens after that. Am I understanding that correctly?
I think maybe almost, but not quite. So one thing, I don't know whether, first, can I just check, when you say fabricating, do you mean really fabricating? So inventing the scenarios ourselves or creating them with an LLM?
I meant
Because that's not what I
no,
mean.
no, no. I meant fabricating, as in you need to make up some scenarios. So you would create a test set of
That's what I'm
some
interested in
description where you
testing.
would put into
Mhm.
that all of the different conditions and scenarios that you want to test, sort of thing. Maybe the use of the word fabrication was not the right use, but
Yeah.
you've designed
Yeah.
upfront all of the different states in which you want to test from, presumably.
So, well, I would say more that that's the possibility that you can do. So, the way I imagine this is working is, let's say that we've just implemented a new process for how to gracefully handle a customer failing to log in, right? When they have authentication failed. And now we want to see how the bot will handle that in real life, because we don't know how the customers will react to that. And this is obviously something that cannot happen in the first turn. So I would, yeah, in that case say, okay, this is what I've just implemented. So now I will grab a bunch of production data where I can see, from one of the metadata columns that authentication failed. And now I want to grab all of these. And for each conversation, I want to basically overwrite the bot with the state that was just before that failure happened, or sorry, well, just after that moment that the failure has happened. And I want to realistically, inject all those variables into the state and then see what the bot says next. And then I want to repeat that for 1,000 different conversations where everything that got up to that point is different for the different conversations. But I'm really interested in, at this crucial moment, what does the bot do?
Right.
Now, the thing that's tricky is how to accurately inject that state. But what I have found through thinking about it, and as I describe in my blog, the good news is that even hacking that in the real sense of being hacky about it, being quick and dirty, that can still potentially be useful and give you some actionable insights. And I've found that it's basically, at least when I think about it, it's essentially a continuum of the more realistically you can time travel your bot into that moment of the conversation, then the more you'll be able to test. But I verified it in a little POC myself, where I literally just I took the conversations from my colleagues who were actually manually running end-to-end tests. They literally called the bot and spoke to it, and had different they had different goals in mind, because this was a manual test. So we knew what we wanted to trigger in the end, but we also had described the steps we wanted to go through. And I just literally took my colleagues' utterances, threw away what the bot had asked them in between, stuck those together and sent that as the first utterance, because I don't yet have the architecture to be able to properly, update this state with that this was turn A, this was turn B, this at this point, this information was extracted, blah, blah, blah. So I just did this hacky version of concatenating all those utterances from my colleagues who were playing the customers, and just gave that to the bot. And I could see that what it then predicted as, say, the final routing target was actually the same as what they had been aiming for with that manual test. And so that's really nice, because that shows that even this really, really simple version was still useful, because now we can see, okay, when now we know that multiple turns are getting to roughly the same answer as if we'd really gone through the bot. And that means we can now, say, take a bunch of production data of multiple turns and do the same thing, just concatenate the customer sides of the conversation, ignore the bits in the middle, and at least have a feeling of what our bot would probably say in the end. So it's not necessarily something we need to then make ground truth labels for this, but just, again, to compare the distributions of, okay, if we were to just go live with this, would we suddenly start sending 3 times more customers to billing than before? If so, that's bad. So you're already getting actionable insights from the more simple implementation of this. But of course, this wasn't a realistic test, because certain actions from the bot are only available at certain steps of the conversation. And once you can implement that properly, so that you can really, for example, fill this conversational state and exclude whatever possibilities would not be possible at that stage of the conversation you're trying to test, then you're going to be able to test more realistically, and have more faith in what it does next, that's a realistic test. But there's this continuum, and yeah, that's the way I think we'll go about it as well, probably. Does that make sense?
Yeah, it makes sense. Yeah. What's your thoughts on synthetic data for doing this kind of stuff? Because I know a few platforms kind of have, they'll have like, I don't know, they call them like conversation simulators or something like that. And so you'll kind of describe to it, I'm this person in this situation. This chatbot is a telco chatbot. I'm moving house. Create me a conversation. So this is is fabrication, basically. Like, create me a conversation script, essentially, that is intended to test this. Create me 1,000 of these with different variations, and we want to test that. Like, so some platforms are beginning to get to this stage now, where essentially it is all essentially synthetic conversation data geared to testing the efficacy of multi-turn dialogues. What's your perspectives on that?
Yeah, this is something that I have definitely got thoughts about. First of all, synthetic data for these earlier stages of exploration and stuff, I think that's perfectly fine. It's very useful. Also, ideation. You can say, okay, think of all the most crazy ways that a customer might be able to express this intent, because then that can make you realize, I really need to include this and this and this as possible examples in my description. Or you can flip it on its head. You can say, hey, this is the description I've got for this business process. Now, here are a bunch of customer utterances that should have triggered this, but they didn't. Can you spot any trends of why it maybe went wrong? And can you maybe now help me suggest, how to update my description? So working with, this kind of synthetic data and using the LLM as a evaluator and stuff, I think that in the exploratory stage, that's really good. But for this real benchmarking, maybe it's because of my machine learning data science background, where real data with all its warts and ugliness is the holy grail. And so I'm deeply concerned by simulating all these or synthesizing all these conversations, because LLMs are trained to speak in fluent, beautiful prose. They're not designed to ask about Swisscom specific products and services while on a busy tram in the middle of Zurich, where the speech recognition is making random errors that no LLM could ever predict, because they can be just so random, or someone can say something in the background, and then you can really see these transcripts that they're almost impossible to understand as a human. And you can ask an LLM to try to talk like that, but I find that very hard. They are so determined to speak properly that I think that's the first problem, is that data just won't be realistic. And the other problem that I have, or the concern that I have, is, let's say we have built these business processes, so if you're unsure between this process and this process, then you should trigger this kind of disambiguation question. And then if you're still unsure, you should ask this kind of more detailed disambiguation question. Let's say we've got some logic defined like this. And then I've got an end-to-end test, which has one example of this from start to finish, that we use, with those automated end-to-end tests to check that our logic is working. Okay, that's nice. But if I now want to say take that end-to-end test and say generate 1,000 conversations like this, I don't know how much extra that teaches me, because the first one was okay. And if I'm not getting the benefit of this messy data, then I'm not sure how much else it's bringing. And the other problem is that if I have accidentally made any oversights in terms of, a kind of customer utterance that's actually really borderline between two different topics, and I just never would have thought of it. If you've made those logical oversights, then asking an LLM to generate conversations, it's just going to generate conversations that have that hidden oversight in them. So this is why I'm such a fan of testing with real data. So that's my concern about that. But as I said, very useful in the beginning. I don't want to take away from that. That's for sure.
Very good. That makes perfect sense. Absolutely. Concur. There was one thing you mentioned earlier when you were talking about RAG, and you were talking about how sometimes the question that is asked is very ambiguous and it requires a bit of back and forth. It's almost like you were sort of alluding to how a RAG solution also needs to disambiguate potentially by encouraging the user to explain a bit more and then concatenate that and explain a bit more until it's got to the place where it can do that. Is there RAG in your current solution? And if not, are you thinking about including it in the same sort of like way so that you still maintain this classification system that you've currently got? And then that does the disambiguation, so that only when you're happy that you've got something that you can match an intent to, then you will then devolve to the RAG. Because I know some have done it another way where they've got RAG up front and center, and RAG's actually doing a lot of the classification as well. I'm wondering if you've thought about how to introduce RAG and its disambiguation requirements into this orchestration classification solution that you've got.
Yeah. I mean, firstly, let's not forget we have a whole dedicated RAG team. So I sort of, because my team is quite early in our journey, I kind of just have faith in that RAG team that's working on this. And I know that they're also already getting practice with that with the chatbot team, because the chatbot is much more advanced. So that, I believe, has already some nice RAG functionality in there. And the RAG team is just improving all the time with, even the boring stuff like the document indexing and cleaning up the data and all these kind of important things. For us, or what I've seen in general in the group, and from my other research and stuff, is I think a simple approach that a lot of companies maybe take at the start is just always do the RAG. So the customer says something, so in the background they do a document retrieval query, they prepare a possible answer, and then they just serve that up as one of the possible options the bot can take. So the bot can choose to trigger one of these processes or use this answer. And that makes sense. That's kind of fair enough. But the problem with that, of course, is that if it chooses not to use the RAG answer, if one of the business processes is fine, then that's an absolute waste of latency and token cost and all this sort of, and energy, which concerns me a lot in my line of work. And so what I'd like to do when my team gets to that is to be a bit more like, okay, well, let's just essentially let the bot ask for help. It's almost like on, Who Wants to Be a Millionaire? Like, do you want to phone a friend? So it's sort of, here's what the customer said. Here are all the different business processes that we have. But if you're unsure, you can also put your hand up and say, I need more help. And then we could do a RAG query. And that should already cut that down a lot. And I think it'll make it a little bit more intentional. And what I would actually do is, once we have our document database nicely indexed, I'd love to also have metadata that includes the topics that are in each document. And that's actually crucial to do before you split each document into the individual chunks. Otherwise, a single chunk kind of, might lose the meaning because it's only really makes sense in context of the whole document. But so I'd like to have all the chunks with metadata about the topic, so that the bot can not just put up its hand and say, I need more information, but actually, have a slot that is, I need more information on this topic, right? Because it has a feeling that, like, it's not sure, is it process A, process B, or could it maybe about this topic? And could I maybe just answer this with an FAQ? I'm not sure. I need more information. And by doing that, it's actually almost an agentic kind of behavior, in the sense that the LLM is asking for specifically what it needs, but it's so much more controlled than an agent system, and it's just very simple. And then, of course, when it asks for that extra information, we can grab documents that match that topic that it's asked about. We can make a potential answer for it, and then we can basically give it back. And then it's got the choice. Then it's sort of like, okay, I was originally thinking it was either A, B, I wasn't sure, and I thought maybe it could be this other topic. Now I've got this extra information, this other topic, and now the bot might decide, yeah, okay, that's perfect, and play that information out to the customer. Or it might think, that actually was not very helpful. Now I do think it was probably just option B. Or, you know how it is as humans, you get new information and it can cause you to completely repass what you had in your mind before. So it might be sort of like, I get that first customer utterance now. It means this. Okay, then it's clearly option D. I didn't even have that on my radar, but now I understand. And so that's how I'd like to be doing that. Yeah.
That's really interesting.
Sorry, it's not very concrete yet, but that's because we're not up to it. But that's think
No, but
about it.
it's good because it's a different way of doing it. Because as I said, like, the ways in which, because the problem is essentially, I call it the full stop problem, and it's part of the full stop problem.
Yeah.
I don't know if you've read it, which is that, like, rags. The trend at the moment is rags everywhere, rags everything. But the massive problem is that RAG basically is just a search, and whenever it responds with anything, it's going to give you a response based on the information that it's got and however it's summarized it, and it doesn't have contextual awareness, doesn't have awareness of the conversation, doesn't have awareness of all those other services and use cases that you spoke about, and so it'll just answer the question, end in a full stop. And kind of like part of the issue is that if you just use RAG on its own without anything like this classifier that we're talking about, then it can't differentiate between what a question is that needs an answer and what a service is that needs an automated fulfillment of some description or handing over to an agent or whatever it might be. And so the ways of solving that is that either you, and the ways I've seen it kind of being solved with other kind of technology companies, is that one side of there's a few ways actually. One is that use NLU, keep NLU where it is, and NLU should do as best as it can to clean up as much as it can, maybe 70 or 80% of the things that come in it can handle, and then devolve to RAG afterwards. Because if you've got your services in your NLU and anything that's not part of that is RAG, that's one approach. That's more companies that have already got an existing NLU solution tend to do that because it's easy enough to add RAG into that. The other approach is to use RAG front and center at the top of everything. And within your RAG database, you've got a description of all of your services and then deep links into those services, and you retrieve them that way. Which, again, I don't think it solves the conversation management problem. It might solve the problem of getting people to the right place if you've got a link in your app or whatever it might be, but I'm not convinced that does a good enough job of solving the conversation management problem. So in your scenario, which seemingly is the third way of incorporating RAG, is that you've got your LLM classifier kind of orchestrator piece at the beginning. You're using that to then say, I'm not sure, let's go into the RAG. But then the challenge, I suppose, I'm trying to work out is that your RAG pipeline likely will have a series of prompts associated to it, which is, before I retrieve anything, check this customer utterance, find out whether you think our topics are going to be covered in here or not, is number one. Because if someone's asking what the weather is, there's no point in doing a RAG retrieval on that because it's not going to be in there. And then so you've got these kind of like guardrails and these chains of prompts that you kind of run through to kind of like monitor the quality of or make sure you're retrieving the right kind of stuff. You may have the disambiguation question to deal with, and the question is, where does that happen? Does it happen before the RAG so that you can round out the topic area a bit more successfully and then push that into the RAG, or does it do some kind of retrieval, realize that it's got a little bit left to figure out, and then go back and do some disambiguation? So I suppose it's like TBC in terms of how that sort of worked out. But yeah, I think that your approach in terms of how you're thinking of incorporating it probably, at least the idea being, I think it could work better than throwing everything to RAG, because I think that, the limitation there is that everything's a question, therefore everything gets an answer, whereas the reality is that only some things are questions and some things are actually services or outcomes.
Yeah, that's right. Yeah, I mean, I think, so the thing with this approach is basically at every stage of the conversation, so after every customer turn, then the bot is again getting this reminder of this big prompt. Your job is to figure out what is the best thing to do for this customer. Here's all the different possibilities, and here's what the customer, or here's what transpired so far. So it has the history of what the customer has said and also what it has asked. So that means that helps with this disambiguation, because until we implemented that, we had the problem that the customer would say mobile, just mobile, and the bot would say, okay, are you calling about a technical or an administrative issue about your mobile or something else? And then they would say administrative issue, and then it would say, okay, so which product is your administrative issue about? So it was forgetting that it already knows it was mobile. And that was a simple tweak, but we had to put that history in there. So now it knows this is what has happened so far. And I think that way with this RAG option, it'll be able to before it triggers RAG, it'll know what's happened so far, and it'll make that choice of I need to put my hand up and phone a friend now. And then once we retrieve that document for it, it'll again be then given this scenario of, okay, you're a bot, Your job is to, find out the best thing to do for this customer. Here's all the different options. Here's a bit of information that might help you, that you asked for. And here's the conversation so far. And then it can, decide to use this RAG answer, or as I said, it might now understand the problem differently and go for a different final solution. So I think that will work. And also in terms of tackling the full stop problem, the nice thing about this is that, of course, it can then, play out the RAG answer, but we always, after any sort of process is complete from the bot, it of course asks, what else can I do for you? And so right now that's, I would say, quite a simple thing where, it's not necessarily maintaining all of that, remembering from, if the first utterance was a multi-intent, it won't right now remember that, okay, I've just dealt with the first part of that customer utterance. Now I want to go back and say, oh, and by the way, you also mentioned this, let's start that. But I think that will come, we'll be able to do that. And that will help, avoid this full stop problem.
Yeah. Yeah. I mean, there's more beyond that as well, which is that like the full stop problem is not necessarily strictly just invite the next turn, as in how else can I help, but also contextually invite the next turn. So, for example, if someone says I've got a billing issue, I don't know, let's say that, maybe that's a bad example, but hypothetically, someone says I've got a billing issue, the classification solution tries to figure out what to do with that. It can't figure it out. It goes to the RAG. The RAG then produces a response that says something along the lines of, usually billing issues are a result of some kind of miscalculation. We'll rectify it for your next bill, so it should be fixed in the next cycle, and so don't worry about it. Anything else I can help you with? Now, maybe this customer's situation is such that their billing is a situation that needs to be dealt with. Or another example in the telco world would be a customer says something like, how do I update my contract? And maybe the classification thing says, well, we don't have any automated journeys for renewing contracts, so I could put this through to an agent, but it's just a question. They've asked, how do I update my contract? So maybe I'll send it to RAG and I'll get an answer, serve the answer, and then 9 times out of 10, what will happen is they'll be told how to update the contract, pay off your contract, find a new phone, take out a new contract, full stop. But then what you want is, because you know that there's a service related to this, you kind of don't want to say anything else I can help you with. You kind of want to say, do you want me to put you through to someone now to talk about it? Or do you want us to get you logged in and find out how long you got left on your contract? Or have you found a phone that you really like? Do you want us to price you up a deal? You kind of want to get that conversation moving more towards the outcome, which again it's related to state management, but it's also related to your content being labeled with topics, as you kind of alluded to earlier, but also those topics being associated to services or to products or to things like that. And now all of a sudden now you need, seemingly, at least the way I think about it, is you need some sort of ontology or some knowledge graph behind there that understands the relationships between content and services and products, etc., that you can then use to say, right, this customer's asked 3 questions about new phones. Maybe we should just stop answering those questions and just ask them if they're interested in speaking to someone about update. Do you know what I'm saying? Like, there needs to be some intelligence about the journey and the conversation to be able to guide it into the right direction.
Yeah, absolutely. And as I said, I think we'll get there. So for now, the simplest solution is, as I said, this quite basic question of, can I do something else, is quite naive. But I think you're totally right. And that's actually why, to come all the way back to the beginning, using an LLM as a classifier is not such a bad idea in the end, because you have these general business descriptions. And I want to be clear, they are general. It's not, we don't have one description for every single individual thing that can be done, but it is, administrative type inquiries such as blah, blah, blah. You've got a bunch of examples. And the bots are so good at understanding natural language and being clever enough to recognize, that's an admin issue. I think that it'll be quite easy for the bots to, play out a RAG answer or answer, 3 in a row. And then, because it's always, after each turn, it's always given the history, at some point, it's also going to, if we have, we just need to update our descriptions to, for example, the sales description. You only need to have a phrase, something like, trigger this if the customer is clearly has some kind of sales intent. The bot's going to figure that out. If it's not clear on the first utterance, I feel that by the time it's answered 3 in a row, I'm quite confident it will figure that out. And so actually we'll be able to, because then it will just realize, I need to stop triggering RAG flows and just trigger a transfer now to a sales. That's clearly the most obvious thing to do. So I think that's going to work.
Yeah, definitely. Last question, I promise. I know we've been going for a long time now. Very last question. Do you think that there's a scalability issue here? Because, you've got one master prompt, which has got a description of all your business processes and everything that it should do. Let's imagine that you incorporate RAG into that. And then now you maybe in that same prompt, you say, we've got these services that have got use cases. We've got these things that are agent escalations. This type is that type of agent. This type is that type of agent. And also we've got all this information based on these topics that we can answer questions about. And so that prompt can start to get quite large. And then over time, there's new use cases that come around, and therefore you have to update that prompt. And the question is the prompt still going to adhere to everything that's in it, or something's going to get lost? And as you're maintaining that over the course of a conversation, as you're adding context and you're keeping the history of the conversation, etc., the prompt's expanding and getting bigger. Maybe there's other things to consider that kind of grow. And so, like, one, maintaining the integrity of that prompt is going to become crucial. But two, do you envisage a scalability issue at some point where context gets lost or things get skipped because we're expanding the context window of that prompt so greatly?
Yeah, no, that is going to probably come and bite us on our backsides at some point. What I can say is at the moment, even though we have so many different business processes, they won't, and I keep referring to this one giant prompt. I'm simplifying this because I also don't want to reveal our secret sauce and stuff, but we won't always show every option. It will be contextual based on what's happening at the moment. So that will help us to not get completely overloaded. It still could end up getting bigger and bigger and starting to bust the context windows of the bot, especially when you consider that conversation history part getting bigger and bigger, especially if there's been a few RAG answers. And honestly, I'm not sure how we would tackle something like that. We've got to move one step at a time. Maybe one thing you can do is, whenever there's been a turn that involved a RAG answer, then you could call a very small, lightweight summarizer to just summarize that point into as simple as possible, sort of 1 or 2 liner. Of course, every time you're calling LLMs left and right, you're adding latency and costs and things like that. But when the scope of the task is small, like just summarize this one response, then you can often get away with a smaller, faster model. But yeah, that will remain to be seen, actually.
Interesting.
Let's see. And then if we come to a real barrier of that, then I'm not sure how we'll figure it out. But this is again one reason why this sort of classification approach is nice, because you can also you can do that a bit hierarchically. So you don't have to describe with because few shot prompting is quite useful, where you have examples for the bot, but you don't have to have an example for every single administrative thing you can do. You have the general topic and a few rough examples, and it works. And in fact, I'll finish with one nice little anecdote to show how much more scalable this is than the old approach. As you know, the old systems, they might have used some machine learning and stuff, but often there was also these syntax rules especially for very specific topics, like case of death that I mentioned earlier. That was basically being recognized by if the customer is using some very, very specific words about death. And of course, we know that there's many ways to express that someone has passed away, and we know we're going to miss a lot of them. And now that I've implemented this, just this week last week I was working on this, and just for a bit of fun, I managed to get it to even recognize that this customer is pining for the fjords. And I don't know if you recognize that Monty Python reference, but in the old days, there is no way you could ever get the bot to recognize that is about a case of death, but now it can. And this helps with that scaling problem, because you don't have to explain everything to the bot. You can explain things pretty generally, and as a classifier, it's actually pretty good at then figuring out with common sense, what you're talking about.
Yeah, so. Which plays to the strengths, understanding the vast variety of language is exactly where it's most useful. And I think that most recently, I've kind of been encouraging individuals and companies to think about things. You mentioned like microservices earlier on. Think about things in that kind of way. What is the way in which you can create a little slice of capability that just does one thing really, really well? I think that sometimes people bite off more than they can chew with these agentic applications, and they try and have models do absolutely everything. And it's like the potential for chaos in something like that is huge. Whereas if you just say this one thing is going to do this one thing and it's going to do it really, really well. And therefore, you're kind of like, you're minimizing the amount of chaos that can happen in any given part of an application. You're increasing the amount of order that can happen. And, kind of you're instilling a little bit, not quite determinism, because that's not the word for it, but predictability is what you want. And by isolating specific capabilities and creating functionality that just does that one thing really, really well, you can minimize that kind of like variance and you can increase order, therefore you can create more reliable systems. I think this example that you kind of sharing here with classification is a really great example of that. All we care about at this moment in time is distilling this down, or this word, or this sentence, or this number of turns into this one label, and that's all we need from this application right now. We'll solve everything else later. I think thinking about it like that is really helpful, because it means that you can optimize that thing to do that one thing really well. And once you can get that thing that does that one thing really well, you can then have something else that does the next thing really well, like RAG, a RAG module that does RAG really well. And all of a sudden you can start to piece together a solution where every component part does a very specific job really effectively, and bring them all together to create something that would be far better than what you would have had in the NLU world. So it's really, really great to hear the progress that you're doing and the approach you're taking, and thanks so much for spending a long overdue amount of time, and also an extended period of time.
Long. A long conversation.
No, long overdue, because we've been planning this for a long time, but also for sticking around and getting to the bottom of all this is appreciated. Nice one.
No problem. It's been a pleasure. I've got 1,000 more things we could talk about. Maybe I need to come back 2 more times and get my own hat.
Yes, definitely. The door is always open. And if you want to do part 2, if there's more that we've left on the table, then let's definitely do part 2. I'm keen for that. Yeah. Cool.
Yeah, great. Hey, thanks so much.
Nice one. Thank you so much, Katherine. Really appreciate it. Thank you all for tuning in. Such a deep episode, that one. Really, really valuable insights in that. I'm sure you got a lot from it, as I did. Thank you so much for tuning in, and we'll see you again on the next one. See you soon. Bye now.